Alright, so this is going to be a video about limits and some of the different ways that we can find limits by doing different mathematical operations. Often if we have polynomials, we want to try and cross off some value. The limit is going to make a variable approach a value. And when we get close to that value, we get a math error. So what we're looking for generally with polynomials is to factor them and cancel off a factor on the top and the bottom that make a math error when the variable goes to that value. Looking at 11, for example, here we have the limit as x goes to 2 of x squared plus x minus 6 all divided by x minus 2. Here we can see if x is 2 on the bottom, we have 2 minus 2, which is 0. We have the top divided by 0. Here we have a math error. This equation is undefined at that point. So what we want to do is find an equivalent equation that we can sub 2 into and not get a math error. An equation that acts exactly the same as this one, just without the math error. And the way we do that is by factoring that top part, by factoring the x squared plus x minus 6. When x goes to 2, that's a problem. So in other words, we want to see if we can factor out x minus 2 from this top equation. To check that, what we do is we let x be 2 in the top equation. That's going to tell us the remainder when x is 2. So by the remainder theorem, if we let f of x be x squared plus x minus 6, we know that x minus 2 is a factor if f of 2 is 0. So to check, if we put in 2, we get f of 2 is equal to 2 squared plus 2 minus 6, or 4 plus 2 minus 6, 6 minus 6, which is 0. So since this top part here is 0 when x equals 2, we know that we can factor out this bottom part. We can make that polynomial, x squared plus x minus 6, we can make that as a factored form of x minus 2 times something else. I think the fastest way to figure out what that something else is by doing synthetic division. So we have x minus 2 minus times, if you're not familiar with synthetic division, look up something else on synthetic division before continuing. I'll just kind of briefly go through it as we talk through. So synthetic division sets up the values in front of, the coefficients here. The coefficient in front of x squared is 1. The coefficient in front of x is 1. The coefficient in front of minus 6 is, well, it's just minus 6. And the way synthetic division works, we have this minus 2 involved. It's simulating long division, if we were to do long division with these polynomials. First step is we bring the 1 down. We do 1 times minus 2. 1 times minus 2 is minus 2. Now we do 1 minus negative 2. In other words, 1 plus 2, which is 3. Now we do 3 times minus 2, which is minus 6. And we do minus 6 minus minus 6, or minus 6 plus 6, and we get 0. We knew that it was going to be 0 remainder by the remainder theorem, but this just shows us we got a remainder of 0 regardless. The answer that we found down here, the 1 and the 3, that relates to 1x plus 3, the remaining bracket when we have divided this polynomial by x minus 2. In other words, we can write our limit like this. The limit as x goes to 2 of x minus 2 times x plus 3, because x squared plus x minus 6 is x minus 2 times x plus 3. If you FOIL it out or expand these two brackets, you can find that out as well. and this is divided by x minus 2. We can see we have the same factor on the top and the bottom. So here we can cross these off only if x is not 2. By the definition of the limit, we don't actually let x be 2. X approaches 2, but since x is not exactly 2, we're just approaching that value. What we have is the limit as x approaches 2 of x plus 3. X plus 3 is an equivalent equation so long as x is not 2. It behaves in the exact same way as x squared plus x minus 6 divided by x minus 2. The only difference is if we plotted this x squared plus x minus 6 divided by x minus 2, it would be some graph like this where it behaves like y equals x with a y-intercept of 3. It would be something like this, but at x is 2, it's undefined. It has a hole in it. So essentially what we're doing is instead of using that equation, we're using this one. We're using x plus 3, which is not undefined at that point. It behaves exactly the same way, with the only difference that it's not undefined at 2. This is x plus 3. This is x squared plus x minus 6 divided by x minus 2. Okay, so continuing this limit, here we have a polynomial. When it comes to polynomial equations, we can simply put in the value of 2, we can substitute that in, so long as it's not undefined there. And we can see that this polynomial is defined at x equals 2. We're going to have 2 plus 3. The limit in this case is 5. Alright, I hope you found that helpful on solving limits here. I'll potentially solve some other ones in a different video.